A very good afternoon, everyone. Thanks for the introduction, John. My name is Vishal. I hope I'm audible. I have this unenviable task of being the first speaker after lunch. So I seek for your support so that both of us can conquer the Z monster together. So I hope you'll be on that journey with me. We have heard a lot about APIs these past 2 days. And APIs have been around for a very long time, I would say, albeit in different shapes and different forms. And there are a variety of drivers for customers adopting APIs. We have heard a lot of reasons why banks, why different types of customers adopt APIs. In my opinion, one of the biggest reasons why customers today are embarking on the API journey is because of agility. They want to gain business agility. They want to have the ability to get their products, their solutions to market faster than before. Amidst all of this innovation that we see around us, one of the things that we often tend to overlook is a fundamental and very important part of the entire stack, which is the infrastructure. Because the infrastructure is a foundational aspect that will be very critical in ensuring that you are able to successfully gain your agility type of goals that you have set up. So that is going to be the central theme of my presentation today. And what I want to do as a start is to bring all of you on a history journey around APIs. So I invite you to that. And there are a variety of versions that you might have come across. And this is my version based on my experience with APIs over the past 10 to 15 years. I said 10 to 15 years, and after this, you'll know why I say 10 to 15 years. API as a term is new, but in essence, it has been around for a long time. I apologize, the fonts are a bit small, but I'll make up for that by explaining what you see on the slide here. So APIs really, they were around as early as the 1960s to 1980s. So a very important thing happened in the 1960s. The credit card with a magnetic stripe was invented by a distinguished engineer from IBM. And that makes a lot of the things that we do today in the digital world possible. So if you think how that card works, you swipe, and then what will happen is it will trigger some functions, some subroutines that is residing on your mini computers, right? So that's basically an API. It's a collaboration, it's a communication that happens between what you do at the front end with some logic that is residing at the back end. Then when we move a bit further, in the 1990s, this was the age of Windows Server, client-server distributed computing. I spent this time doing a lot of codings using dynamic link libraries, if you know DLL, and then how DLL got a very bad name with something called DLL hell. But I really like DLLs a lot. I also did a lot of programming with another technology called OCX, Object Control Extension for Microsoft. It's like an API to build front ends. And then there was also the lower end things that Microsoft introduced as part of Windows Server called VXDs, Virtual Device Drivers. But you think of all of these, what are these? These are basically higher level abstractions that allow you to talk to some lower level functionality. So in essence, APIs of a different shape and different form. But something else happened during the 1990s. We saw the birth of, I would say, arguably still one of the most popular languages around, Java. Java was born. And with that, we saw a new wave of distributed architectures. And that's where we saw the rise of XML over remote procedure calls. And then we moved further to the 2000s. This was the age of the internet. The internet really took off in a big way in the 2000s. At the same time, another technology, virtual machines. So when this happened, we also saw something else, some other phenomenon. We saw companies such as Amazon, AWS come to the scene, Borders, Barnes and Noble, eBay, and a lot of these companies were experimenting with APIs. That was their business model. But the type of APIs that they were using was very different. It's XML over SOAP, or what we call as web services in those days. And then from 2010 onwards, we had another format of APIs, JSON over REST. So the data format is JSON, the protocol is REST. And this was also the time of the public cloud providers, big data, analytics, social media. And then today, 2020s, we have APIs of a different format. We have heard a lot of talk about open API. So I would classify that as a different class of APIs that is very specifically targeted towards industry requirements. For example, in the telco sector, there is something called TM Forum, and there are TM Forum APIs that expose a telco's functionality so that telcos can then integrate with third-party partners to provide value-added services to their customers. Now, and in terms of the API formats, it's changed again. It's become GraphQL is gaining a lot of popularity, so is gRPC, and we have heard some sessions about that as well. Now, what do you notice about this? We see how APIs have been around, but they have evolved. But if you really look at why they have evolved, one thing becomes very clear. APIs have evolved because the underlying hardware and infrastructure architectures have evolved. So let me give you an example. In the year 2000, why did we really come out with XML over SOAP? Why? That is because when you develop virtual machines, you're going to have a lot of private IP addresses. How do you make all of this accessible to your public customers? HTTP. And XML ran on HTTP, so it made a lot of sense. Then when we moved to 2010, why did we move from XML to JSON? Because XML is very verbose, very heavyweight. And that was the time of mobile devices, and back then we only had 3G. So we need low packet footprint. We can't have a lot of data. And that's why we invented this. And today we have gRPC, we have GraphQL. Why? Even though we are in the area, in the domain of 5G, but then we have a lot of use cases pertaining to age requirements. And at the age, bandwidth is still very scarce. And that is why we have come up with new formats. So the key takeaway here is that infrastructure is a very, very fundamental part of how API has evolved. So what I'm going to continue for the rest is to start from where we have left and then take off from there, which is from the 2020s onward. What do we see happening in this whole space of APIs? What are some of the trends that we see? One of the most dominant trends that has taken all of us by storm is cloud. Customers are embracing. Let me just maximize this. Okay, customers are embracing cloud in a very big way. These are some data points that I captured from Flexera's 2023 State of the Cloud survey, very recent. Two things here. Hybrid cloud is on the rise. Multi-cloud is on the rise. So what that means is customers today have a lot of options to deploy their workloads, to deploy their APIs. They could do it on their on-premises data center. They could do it at a managed service provider. They could use one or more of the public cloud providers. There's a lot of choice. And with choice, what do you get? You get the freedom to try out the best options that work for you from a strategic angle, from a finance angle, from an efficiency angle. And why this is important in the domain of APIs? It is important because today customers are increasingly looking at the most flexible way to deploy your APIs. This is something that I captured from the Google Cloud State of the API Economy report of 2025. And 50% of the respondents say that they will see an increase in the adoption of hybrid cloud APIs. So what does that mean? That means that your APIs can reside on premises or in conjunction also with a cloud or one or more cloud providers. And why would they want to do that? It could be for cost reasons. It could be also for based on the type of APIs they are building. So you could have APIs that are going to serve data that is very sensitive in nature. And you want to store all of them on your on-premises data center. And then you have other APIs that are serving more public data, and you could have it on your public cloud. It could be due to that, or it could also be due to the type of cloud providers that you have chosen within the company. It is not uncommon for large organizations to have more than one cloud provider, as what is stated by the Flexera survey. So what that means is that you unintentionally will be having multiple different API deployment options. So what this means is that you've got to be very aware that your deployment configuration, your deployment infrastructure is going to be heterogeneous, it's going to be very hybrid. Another trend is mixing and matching API gateways. So if you were here for the presentation by Manjunath from Gartner, one of the things that he mentioned on his last slide is that Gartner sees customers adopting multiple types of API gateways, which is what I have seen over the past 5 years. And why do they do that? For several reasons. One of them could be they don't want to go all in with one vendor. Obviously, a vendor will tell you, go just use my solution and my entire stack. But we all know that there is a risk of lock-in, and there's a lot of technical debt you can incur over a period of time if you're just going with one vendor. But it could also be due to other things. For example, company A acquires company B, and both of them have been using different solutions. You do not expect them to immediately change because it will have business impact. So what you do is you just embrace and just live with more than one API gateways. So there are a variety of reasons why customers are looking at an architecture that will allow them to be agile while at the same time have the ability to manage and mix and match multiple API gateways. Something else that I want to spend a bit of time talking on is how APIs today have driven a whole new set of solutions. A lot of the things that I'll show here may look very similar to you. You might have seen this, but I'm sharing this from the vantage point of APIs. And there are four key things that I want to talk about. First of all is that today we see that there's a business need for everything to be available as a service. And what that fundamentally requires you to do is to completely evolve your architecture from monolithic to microservices architecture. What will that mean? What that means is your one big monolith application is going to be broken down into multiple APIs, multiple microservices exposed as APIs, and then it becomes a management nightmare. And that is why you see the emergence of API management software, as well as service measures to help you choreograph your APIs. In addition to that, customer demands have also been changing. Today, we live in a world where experience is very important, and digital business demands everything to happen very quickly. So it's imperative that we move from a waterfall approach to Agile and a DevOps-based approach so that we are able to roll out our products and updates and new capabilities, features faster. And hence, we have a lot of DevOps tooling, this entire DevOps CI/CD tool chains that are available at our disposal today. The fact that we are living in a multi-cloud, a hybrid cloud world gives us the ability to scale very easily. But with the ability to scale also requires you to address the whole notion of a distributed architecture. How are you going to manage a distributed architecture? And that is why central management become very important. And finally, the whole notion about agility and interoperability. APIs today are more popular than what they used to be, not just because of the formats having changed, but because the underlying architecture allows you to do today that was not possible previously. I guarantee you, if containers and Kubernetes were not around, APIs would not have seen this much of success, because containers and Kubernetes allows APIs to do a lot of the things that it's able to do today from an infrastructure angle. But then again, right, when you move to container technology, there's this whole nightmare in terms of operations. Operations becomes a nightmare. What you see in the red box here is typically something that if you are part of an organization and from the API department, you do not consider what's in the red box, because that really falls outside the context of API development. But this is something that is very important, because when you are rolling out your API strategy, it just doesn't stop. It doesn't start at the API level and ends at APIs. It needs to incorporate the whole gamut of things that you need to do so that you are successful. You need to address the entire ecosystem. So what does the ecosystems for enterprise and secure APIs look like? It all starts at the compute layer. Today, we have a lot of different compute options, from your data centers to your edge instances to your managed service provider to even obviously your public cloud providers. They provide you the compute for you to then build on your cloud native fabric, your cloud native infrastructure, for which it's very simple. There's a given. There's only one option available today, which is Kubernetes. So that helps you get the basic foundation ready. And then what do you do on top of that? What you do on top of that is then you start building microservices. But as you build more and more microservices, how do you choreograph all of the microservices together? How do you gain observability? How do you gain the ability to manage failures and so on and so forth? And that's why we have the likes of Istio, Linkerd, as well as the open service mesh specification. Once you have all of this, that is when you then build your API management layer. This includes everything from rate limiting to throttling to your API development portal, everything that is part of API management, and as well as API security. That is gaining a lot of traction because security is a top of mind concern for CIOs and C-level executives today. Only after that, you are able to roll out your your API as a digital product, which can then be consumed by your digital channels. It could be your customers, it could be your partners, it could be another API that is consuming your API product. So this is how your entire cloud native ecosystem for enterprise APIs look like. Now, I want to bring across one important point. When I talk about this entire ecosystem, and let's start from APIs, how does the life cycle, the whole evolution and the life cycle of an API looks like? So I would say there are five steps, and you may come across other people saying, well, no, Vishal, there are not 5, there are 10 steps. I'm sharing 5, what I've experienced over the past couple of years with my experience with APIs. It all starts with developing your APIs. And what I mean is cloud native APIs, right? And this means that you write some code, could be in Java, Python, Scala, and then you deploy it on containers. So that container will basically be your source code, right? What happens after you do the API development? You then deploy your APIs, and then you have a lot of APIs. You'll need to have an API management layer to manage your APIs. You also inject security into the mix so that you are not just having APIs, but secure APIs. And then you got to publish it to a developer portal so that your developer community, internal developers and external developers, are able to discover your APIs. And then finally, you have API consumption. You then deploy this API somewhere so that somebody can use it. What is one thing that is very striking here is that everything that you see is going to be supported by containers and Kubernetes. What do I mean by that? Where do you deploy your APIs? You deploy your APIs on your gateways, and cloud native gateways run on Kubernetes. API management and API security toolings also do the same thing. So does your developer portal. And then the place where actual microservices are running is also going to be in Kubernetes. And what I talked about just now, if it's going to be a hybrid cloud world, then it also makes sense that perhaps the underlying infrastructure, which is Kubernetes, may also be running everywhere. I want to share with you some statistics that today Kubernetes is powering the container world. And this is what I got from CNCF's survey. 96% of organizations either using or evaluating Kubernetes. Now, I have quite a few people here. I want to have a show of hands. How many of you within your companies are using more than one distribution of Kubernetes today? Okay, I see some hands, and I also some hands that were not visible, meaning inside they're saying, yes, me too, Vishal. But this is true. So why do they do that? It's the same thing. When you have choice, you want to use more than one. So I want to correct my slide here. It shouldn't be Kubernetes is powering the world. Multi-Kubernetes is powering the container world, right? So if you have multiple distributions of Kubernetes, then things become a bit more complicated. I explain to you very shortly. Besides that, something else that we have seen a lot of analysts, Gartner, Forrester, and IDC talking a lot about today is this whole notion about security. Security is a very top of mind concern. And security in the context of containers is an even big thing, because another data point from the CNCF's latest survey, security is one of the priorities, and it's something that people find very difficult to implement, especially in the context of containers and Kubernetes. It's not easily something that is easily implemented, purely because it's very complex and we don't have the skill sets to do that. I also want to explain to you why things have changed today and why security is so complicated today. Because I've spoken to a lot of CISOs, a lot of network architects, and they tell me that, Vishal, we have done a lot of things in the past in our data centers, but things have completely changed today. And that's why even we are struggling to keep up to speed. And these are some of the reasons why the whole security domain in the context of containers and Kubernetes is very different today. First of all, there is this widespread adoption of containers. And when you have so many people using it, your attack surface increases. Everybody wants to target you because you're using that. And that's why hackers are targeting containers a lot. Secondly, the traditional way that you manage your security is changed. When you just have one data center, security means firewalls, IDS, physical security. When you move to a distributed architecture, it's very different because your perimeter have changed. In addition, Kubernetes, if you have played with Kubernetes, the way it works is that every time you spin up a pod, you have a different IP. And then a few seconds later, it dies and another IP. So IPs become ephemeral. So the whole notion of blocking IP address and all that will not work because everything is so dynamic, everything is so fluid. And plus the whole whole aspect about automating security becomes very complicated. And that is why security is something that is very difficult to achieve. So let me explain all of this to you in a graphical manner. So what you have here is three different type of infrastructures. What you see in orange is the hut, is the data center, and you have the public cloud providers, and you have the edge compute instances. The green boxes are your workloads, your cloud native workloads. And they could be a microservice, they could be your service mesh, it could be your API developer portal, it could be your ingress controller, or it could even be your API gateway. So you have a customer, all right, let's go big bang into cloud native. So what they do, first of all, what you want to do, you want to lay out your Kubernetes, right? So you download, let's say, Kubernetes, vanilla Kubernetes for your data center. For the cloud providers, you decide, okay, let's use EKS, GKE, and AKS. And at the edge, you need something that is lightweight. You decide to go for the most popular Kubernetes engine that is designed for edge environments, K3S. So you have that setup. What do you do after that? What you do after that is you deploy your workloads, right? You deploy your workloads to your cloud environments, deploy them to the edge environments. And then you end up with that, hey, we have so many different Kubernetes distributions from different cloud providers, different types, one for edge, one at the data center. How do I then gain sanity pertaining to managing a distributed Kubernetes environment? Because if I'm not able to do that, I don't even have time to worry about my API infrastructure. So here is one way that you can resolve this. Let's wait for the animation to continue. And this is where I'll do some of my vendor pitch. So Rancher is a solution from SUSE. Think of it as an enterprise container management platform. And what it basically allows you to do, it creates an abstraction layer between your various Kubernetes distributions and a management console. So what you get is a single pane of glass that allows you to manage all of your instances, distributions in a singular manner. And at the same time also providing you with the full capabilities to build DevOps tool chains and also manage your underlying infrastructure. One of the greatest benefits that you get here around productivity is that we all know that getting acquainted with a public cloud provider takes months. So we take all the complexity out of that so that you can focus on building your APIs. And what I mean by that is that when you want to develop your distributed architecture on your cloud providers, we help you create all your Kubernetes clusters, manage them, destroy them, the full life cycle, we take care of that. Because to do it yourself, it's going to be very complex. You've got to go through tons and tons of pages to figure out how it works on the cloud providers. So you get a lot of efficiency that way. At the same time, I talked a lot about security. So there's this whole notion about API security, but there's also the underlying security that you need to be aware of, and you need to take care of that. Because if you don't fix the bugs, the issues at the code level, at the container level, it doesn't matter. Your APIs may be secure, but the source has problems. And that is where a solution that we have, SUSE New Vector, allows you to do a lot of the traditional things like container scanning and those sort of things. But one area where it does something very unique is that when the apps are in the production environment, we also allow you to track protect your applications in the runtime environment. So you may have not found anything from dev to production, but at runtime, because of malicious software of malware, you can still trap all of this. Wow, I just have 2 minutes left. You know, they say that when you're having fun, right, time really flies. But here is what I would like to paint in a different manner. So where we really come into the picture is that the top layer is what we are talking about a lot during this conference, the API infrastructure. And what we allow you to do is to help you build a solid foundation based on SUSE Rancher and New Vector, so that you can very easily build an API infrastructure that is distributed. And obviously then power your digital API products. I want to very quickly touch on 2 examples. So this is an API gateway example, right? So you have your front-end consumer going into your gateway that is deployed on a Kubernetes pod that is servicing traffic and routing the traffic to your different services in your Kubernetes cluster. So what would you do if you have multiple of these gateways? Like I talked about multiple gateways. Well, what I talked about earlier, plugged all of the underlying Kubernetes that is powering the gateways into Rancher and SUSE New Vector, and we take care of that. So it's a separation of concern. You know, your gateway is handled separately, and the underlying infrastructure is also handled very well. Another very quick example here. This is something that I've taken up from Solo. So Solo.io, I have 1 minute, yeah. So Solo.io, they have this solution called federated service mesh. And why I like this is because there's the same problem again, right? What happens when you have a lot of service meshes that are federated across a cloud provider? So you have the service management that's taken care of Solo.io, but then what about the underlying Kubernetes? So this is another use case how a distributed Kubernetes management solution can also help you orchestrate your service meshes across a distributed architecture. So this is my final slide. So how does it look like, right? So laying the groundwork for agile and secure enterprise APIs. It starts off at the base. You need to focus on Kubernetes, management, and security. And we have some solutions to help you with that. And then you layer that with a service mesh solution with management, and there are a lot of options out there. And then you top it out with your API infrastructure solutions, with API security. And then finally, that will be powering and allowing you to develop your agile and secure APIs. And what I mentioned here is that you can use Rancher and New Vector with any of the service mesh and API gateway solutions out there. So that's it. SUSE around for 30 years, open source space, and we are doing a lot of cool things. So I'm going to be very interested to speak to you. I'm still going to be around. Hope you enjoyed your session. API is a fantastic landscape, a lot of powerful things that we can do in the future. So let's get the maximum out of the APIs. Thank you very much.